Now in today's video, we will start with the new topic 3.4 scatter diagrams. A scatter diagrams is commonly used to illustrate the results of a statistical survey or inquiry by comparing the two sets of data. Values of the two sets of data are recorded in pair, and these are plotted on a graph just like plotting a pair of xy coordinates. If these pairs of coordinates points tend to lie on a straight line, we can conclude that there is a close relationship or correlation between these two sets of data. So correlation. The scores obtained by 12 pupils in paper 1 and paper 2 of a mathematics examination are shown in the table below. So figure shows the scatter diagram. When the set of data is plotted, we usually plot the independent variable on the horizontal axis and the dependent variable on the vertical axis. In the case above, where there are no clear independent and dependent variables, so we plot the first variable on the horizontal axis and the second variable on the vertical axis. So the first variable is scored in paper 1 and the second variable is scored in paper 2. So now we have plotted the points as we can see on the graph. Figure above suggests that there is a close relationship between the scores for paper 1 and paper 2. The higher the score for paper 1, the higher it is for paper 2. This is called a positive correlation. We may also use the term strong, moderate, or weak to give a clearer indication of a correlation. We can also show the general trend by drawing a line that will pass through most of the points or close to the most of the points as possible. This line is called the line of best fit as shown in the figure. So now we will taking the now here we have the line of best fit. So as most of the marks lie very close to the line of best fit, we say that there is a strong positive correlation between paper 1 and paper 2. We can use the line of best fit to predict the performance of a pupil who was absent from sitting paper 2. So for example, if a pupil scored 46 marks in paper 1, so here we have to see 46, where 46. First we have to understand the scale on the graph. So scale along x-axis is equals to the 10 minus 0 divided by total number of square between these two points, and this is 10, so it will be equals to 1. Now the scale along y-axis, on same lines we have 10 minus 0 divided by 10, and it will gives us 1. So each square unit along x-axis and y-axis is equals to 1. Now for example, if a pupil scored 46 marks in paper 1 but was absent for paper 2, we can use the graph to determine the likely score he will obtain for paper 2. This can be done by locating the corresponding score for paper 2 from the line of best fit when the score for paper 1 is 46. So as shown in the figure, so from 46 we will draw a vertical line until it intersects the line of best fit. Now from the point of intersection on the line of best fit, we will draw a horizontal line until it touches the vertical axis. So here we have the score 40. So the pupil scored 40 in paper 2. Score for paper 2 is equals to 40 marks. Starting the exercise, we have to keep some points in mind when we are drawing the line of best fit. So the first point is the line drawn may pass through all the points some of the points or none of them. Second thing, the data points have to be evenly distributed on either sides of the line of best fit. Third point is use a transparent ruler to draw the line of best fit. So as to gauge the best position to fit the line. And the one more thing we have to remember, the jagged lines near the origin are used to indicate a broken scale. They are used when values close to 0 are not required. Now in exercise 3D's question 1, state the type of correlation for each of the scatter diagrams below. So in the part A, we will draw a scatter diagram. We will draw a line of best fit, just like this. Approximately same number of points lie above or below the line of best fit. So here we have line of best fit like here. Approximately 3 points lies below the line of best fit and approximately 4 points lies above the line of best fit. So this is a appropriate line of best fit. Now we have to state the type of the correlation. So this is shows the strong negative correlation. So this is show the strong negative correlation. Just because the amount of exercise in a week in hours decreases, the number of sick days in a year also decreases. So that's why it's a downtrend line of best fit and it is showing the decreasing trend. So that's why it is a strong negative correlation. Now here we have drawn a line of best fit and approximately 6 points lies below the line of best fit and 7 points lies above the line of best fit. So this is a moderate positive correlation. Now in the part C, we will draw a line of best fit, just like so. Here we have drawn a line of best fit in the part C, and it shows the strong positive correlation. Now for the part D, we will draw a straight line. There are approximately 7 points. It lies above the line of best fit and 6 points below the line of best fit, but no point lies on the line of best fit, so it shows that there is no correlation between two variables. Now in the question 2, the scatter diagram shows the monthly income earned by individuals with varying years of experience. The line of best fit for the scatter diagram has been drawn. Using the line of best fit, estimate the monthly income earned by an individual with 18 years of experience. First, we have to understand the scale along x-axis. So here we have 2 points. 5 minus 0 divided by total number of squares between these 2 points, and that is 5, and it will gives us 1. Now scale along y-axis. We have 2 points. 1 minus 0 divided by total number of square between these 2 points, and that is 5. So 1 over 5 will be equals to 0.2. So each square root along x-axis is equals to 1, and each square root along y-axis is equals to 0.2. Now first we have to find out the 18 years along x-axis. So here we have 15, 16, 17, and somewhere here 18. So here we have 18, and from 18 we will draw a vertical line until it touches the line of best fit. Now from the point of intersection on the line of best fit, we will draw a horizontal line until it touches the vertical axis. So here we have the value 6.2, 6.4, 6.6, 6.8. Value lies somewhere between the 6.8 and 7. So this value approximately 6.9. And since the monthly income is in terms of dollars and thousands, so 6.9 multiplied by 1000 will be equals to $6,900. So by using the line of best fit on the scatter diagram, the estimated monthly income estimated monthly income earned by an individual with 18 years of experience is equals to $6,900. Question 3. The table below shows the mass of a group of pupils and their respective intelligent quotient IQ score. In the part 1, draw a scatter diagram for the data above. Now we will draw x-axis and y-axis. To draw a scatter plot, so along x-axis we will take mass in kg, and along y-axis we are taking IQ score. Now we will mark the or scale the x-axis. So here we have 0, 40, 50, 60, 70, 80 and 90. Along y-axis we have 90, 100, 110 and 120. Now for 43 and 92, for 43, here we have 42 and 44 somewhere, 40, and we have 92, 92, here we have 92 and 43. So I will put the cross here. Now for 90 and 91, so along x-axis we have 90 and here we have 91 somewhere here. Now for 56 and 91, for 56, here we have 56 here and here we have 91. Now for order pair 47 and 102, here we have 47, 42, 44, 46, 48. So here we have somewhere 47 here, 47 and 102. Here we have 102, so we'll put cross here. Now for next order pair we have 88 and 108. So here we have 82, 84, 86 and 88. Here we have 88 somewhere here, 88 and 101. So here we have 101 here somewhere here. So we'll put cross here. We will understand the scale along x-axis and y-axis first. For x-axis we have 50 minus 40 divided by 5, and it will be equals to 10 over 5, and it will be equals to 2. So each square unit along x-axis equals to 2. Now scale for y-axis we have 100 minus 90 divided by 5, and it will be equals to 10 over 5, and it will also gives us 2. So each square unit along y-axis is also equals to 2. Now we will draw the scatter points on the graph. So for 66 we have, here we have 60, 62, 64, 66. Here we have somewhere 66. For 66 we have 111. So here we have 111 somewhere here, and 66 somewhere here. So here we will get the scatter point. Here we will put this cross. For 110, for 111, and 66. Here we have a cross. Now for 62 and 95, here we have 62, and here we have somewhere here 95. Here we have 92, 94, and 96, and so 95 to 62. So here we have the second cross. Now for 56 and 113, so here we have 56 somewhere here. Here we have 52 to 56, 56 and 113. Here we have 112, 114. So here we have 112 and 114. Here we have 113 somewhere here. So here we have 113, and 56 here. Okay, now for 75 and 94. For 75, here we have 94 somewhere here, 92, 94, and this line 94, 94 to 75, 94 and 75. So here we have 72, 74 and 76, 75 lies somewhere here. So here we have put this cross. Now for next pair we have 50 and 107. So for 50 kgs, here we have 50. For 50 kgs, the IQ score is 107. So here we have 102, 104, 106 and 108. Between 106 and 108, somewhere here 107. So here we have 107 somewhere here with 50. Now we have the order pair 67 and 90. So for 67 we have 60, 62, 64, 66, and 68. Here we have 67 and 90. So here we have 90 somewhere here. So we will put X here or cross here. Now for the next order pair, 82, 106. So here we have 82 somewhere here and 106. So here we have 100, 102, 104, 106. So from we have 106 here. So we will cross here, put cross here. Now for the second last order pair, we have 85 and 100. For 85 we have 82, 84 and 85 somewhere here. So here we have 85 and 115. So here we have 110, 112, 114 and 1 here 115. So we will put cross here. Now for the last order pair, we have 72104. Here we have 72 somewhere here. So from here we will do, and here we have 100. Here we have 102 and 104 somewhere here. So we will put cross here. So this is the scatter diagram for the above data. Now we will, this is scatter diagram for part 1. Now for part 2, what type of correlation is shown in the scatter diagram? So here we will draw a line of best fit. So we will draw a line of best fit here. So approximately 6 point lies below the line of best fit and 6 lies above the line of best fit. So there is no correlation between the two variables.